we're going to do two single replacement reactions. We've got copper chloride, CuCl2, copper 2 chloride, and I've just placed aluminum foil in there. And you see that right away a reaction is taking place. The aluminum grabs onto the chlorine, and eventually you see the reddish in there. That's already the copper metal forming. Copper metal is left by itself. Aluminum is taking over the chlorine gas. We'll look at it in a while. Another one that's just as interesting is magnesium ribbon. We've got magnesium ribbon right here. Okay, it's flexible, silver flexible. I'm just going to roll it up and place it in the copper chloride, copper 2 chloride, and there again we've got an immediate reaction. And this is a single replacement reaction. We're putting a metal with an ionic solution, and these metals trade. So the magnesium here takes over the chlorine, produces magnesium chloride, and leaves copper metal all by his lonesome. We can do a flame test on this later. Let's go back to our single replacement reaction. About an hour later, 2 hours later, we see clearly that our copper chloride is pretty well gone, and aluminum chloride, we've got aluminum chloride and copper. As well with this, we've got our magnesium chloride, which has formed. No longer the nice blue of copper chloride. We've got copper separated from its chlorine. Aluminum chloride is in play, and we'll do a flame test. I'm doing a flame test to see my product, the solid product that came out of copper chloride, copper 2 chloride plus aluminum. My aluminum took over. I had a nice clear liquid and a red solid deposit. And by looking at the flame here, I can tell that my deposit was, you guessed it, copper. Copper is left behind, and it shows up in the flame. You see a nice green flame, which is typical. Green-blue, which is typical of copper metal. And this was in my single replacement reaction. Copper ended up by himself, aluminum chloride combined.